starting from the bottom, we have physical layer. The physical layer is responsible for establishing physical connection between the devices. Next, the data link layer is responsible for the node-to-node delivery of messages. The network layer is responsible for the transmission of data from one host to another. The transport layer acts as the medium between the hardware layer and the software layer. The session layer establishes the connections and maintenance and ensures the security of the network. Next, the presentation layer, it manipulates the data into a required format that is suitable for transmission throughout the network. Finally, the application layer helps in identifying the client and enables user communication. So the OSI model basically helps us visualize and communicate how networks operate. It is not really important that you remember the OSI model because we'll be using only a few layers of the OSI model, but it is important for you to know it. Next. Okay, next we have an example. So this is a real world example. This is a smart home. You might have seen in some of the other movies how a smart home operates, right? So the gates are automated. The gates detect when a person arrives near it, and they open and close accordingly. And the security camera system, the thermostats which sense the temperature through temperature sensor and regulate the temperature accordingly. The lightings which adjust themselves according to the needs of the user. All the appliances are automated, and everything like this is possible in a smart home through IoT. Right? Now, let us get to the advantages of IoT. So firstly, IoT enables easy access. That is, it makes life of a man so easier because all a user would need is a smartphone with internet connectivity, and he would be able to access any information that he requires. So IoT enables easy access of information. Next, IoT technology mainly involves wireless technologies, due to which cities can turn into smart cities. Next, IoT eases communication because IoT encourages machine-to-machine communication rather than people-to-people communication. It lessens the need of person-to-person communication. Hence, hence it eases communication. Moreover, Internet of Things saves money, and also it has a lot of business benefits. So IoT helps explore new business opportunities, and it collects data from the network, and it uses analytics to uncover new business insights and opportunities. So it enables businesses to work according to the customer's needs and analyze the data. Finally, IoT increases productivity. So like every coin has a flip side. Since there are advantages, there also should be disadvantages of IoT. First thing is complexity. So because a huge number of devices are involved in an IoT system, it might become difficult to manage, which leads to complexity of the system. Next, compatibility. So this is important because there is no common standard of compatibility for Internet of Things. We cannot make sure that different devices from different manufacturers can work together. So we might be sometimes forced to buy things only from a certain manufacturer. Next, there is also a risk of losing privacy. So there are security issues in IoT. Since a lot of information is shared in an IoT network, the information is vulnerable to hacking. So hackers might steal the information shared in the network. So proper encryption of data is necessary in Internet of Things. Next, one bug can corrupt all connected devices. Since many devices and all the devices are connected in an Internet of Things system, one bug anywhere in the system is likely to corrupt all the devices which are connected in the system. So, and finally, lesser employment, because obviously IoT makes things automated. So there is a risk of a man losing his job because his work is no more, because machine does his work. Next, we come to applications of IoT. So it is obvious that there are numerous applications of IoT, especially in the modern world. First is IoT helps create better enterprise solutions. Large enterprises have dedicated staff to create, maintain, and monitor their technology infrastructure. So in that case, it helps them manage things and infrastructure and technology efficiently. Next, integrating smarter homes. This we have seen already previously how a smart home works. So it has sensors to control and maintain lightings, to manage resources and security systems. Uh, One example of an IoT-based smart home could be Mark Zuckerberg's Jarvis. So some of you might have heard of Mark Zuckerberg's smart home, where he uses natural language processing for voice commands, and he uses internet switches to operate the appliances plugged to them. And also the lightings adjust themselves according to the needs. The music is personalized, and finally the security system also uses facial recognition to identify the visitors. So if you're not aware of this, you can just Google after the workshop Mark Zuckerberg's Jarvis and watch the video. It is interesting. So this is basically an integrated example of Internet of Things and artificial intelligence. Next, innovating agriculture. So IoT helps in innovating agricultural field. So the agricultural industry can massively benefit from IoT. We can have sensors to provide details of soil chemistry and fertilizer profiles. We can have a smart irrigation system using IoT to efficiently use water for farming. We can also establish a smart greenhouse, and many more such agricultural practices can be done. Next, building smarter cities. So with IoT, we can make a city smarter by enabling traffic management, pollution monitoring, resource management, infrastructure management, smart parking systems, security systems, etc. Next, industrial automation. So since IoT can help machines be automated. So industries can have a lot of machines. It can reduce the manpower. Like it can reduce the use of an employee there. So which is becoming a disadvantage again. But it leads to making industries more efficient and productive. IoT can also help in supply chain management, and IoT can help in transforming healthcare. So, especially in the pandemic, IoT has helped a lot to the healthcare industry. Suppose a patient can have sensors attached to his body.
ऐसा नहीं होता कुछ प्रकार
हाँ. Please mute yourself.
तीव्र बुद्धि
प्रखर का मतलब होता है बस तेज होना.
हाँ.
Prakar. Okay. So IoT helps transform healthcare. Like suppose a patient can have sensors attached to him, and doctors can monitor them remotely. Also, doctors can get to access the medical records of the patient without actually meeting them. And several IoT-enabled healthcare devices have also been manufactured recently, like the glucose monitors, etc. Next, revolutionizing wearables. So wearables is like the hallmark for IoT applications. Wearables like smart watches, Fitbits, fitness trackers, smart eyewear, All of these have already become common in the modern world, right? So next, IoT can also help reshaping hospitality. So hospitality in the sense in hotels, etc. For room service can become automated. Like room service can be made possible through a click of a button, and the gates and the locks can be automated, and the security system can be enabled through IoT. Next, Internet of Everything. So Internet of Things is slowly transforming into Internet of Everything with the addition of AI, ML, and intelligent data. Internet of Everything is the intelligent connection of people, process, data, and things. So these are the four pillars of Internet of Everything. People are the end nodes connected across the internet. Data, it is the raw data which is analyzed to make better decisions. Process, delivering the processes ensure that the right information is delivered to the right person at the right time. And things are nothing but the physical devices and objects that are connected through the internet with each other. So while things is the only pillar of Internet of Things, Internet of Everything constitutes all of these. It is basically a whole ecosystem that where everything is interrelated. So Internet of Things is a broader notion that entails not just machine to machine communication, but also person to machine and person to person, people to people communication via technology. So people use things to generate data, and the data is analyzed and processed so that the information is personalized as per the need of the user. So the goal of IoE is basically to make data-based decisions to extend the capabilities of IoT and enrich user experience. So I think that was enough theory that you should be knowing about Internet of Things. Before we get to the technical aspects of IoT, let us see what is in it for you. How is it actually beneficial for you people? So many companies which are listed here, like Cisco, Bosch, etc., they work on IoT, and they appreciate candidates who are familiar with this IoT technology. So that will provide you with an edge over there. Moreover, if you participate in this event, you can get a unique and exciting project that you can mention on your resume, and that will surely arouse interest in your interviewers. Moreover, since IoT is a recent and emerging field, there is a lot of scope for research opportunities, and it is also a great asset to have for a startup. So if you are interested in research, IoT is there for you. Nextly, in your fourth semester, you'll have to do an exploratory project. So if you're familiar with IoT, you can conveniently build a project. Also, you can include this project also in your resume, so that will help you there also. And finally, it's a lot of fun to build because you'll have to bring out your creativity and you'll have to be innovative when you think of how to solve a problem. Since there is no standard way of approaching a problem, uh, how you approach the problem and how you implement it and how creative you are while doing it is what matters in IoT, in this event especially. So now let's get to the technical aspects of the Internet of Things. So Ajinkya will now take over. If you
Good
have any
evening,
doubts,
everyone.
you can unmute.
Yes, I was going to say the same thing. If anyone has any doubt, you can unmute now and ask.
Or you can type it in the chat box. Okay, let us continue, Ajinkya.
So is my screen visible? Anyone can confirm? Sujal?
Yes, it is.
So first of all, how many of you are familiar with the word Arduino? How many of you know what is Arduino? Please raise your hand or unmute and speak, because now I want this workshop to be interactive a bit. You must have heard the word because it is already the talk of the town. Internet of Things, there are only few words which you hear again and again. You hear 5G, you hear Arduino, you hear Raspberry Pi, you hear sensors. Come on, anyone? Okay, acha, you have raised. So, who is this? Rahul Kumar. Had raised their hands now.
Feel free to unmute yourself.
Yes, unmute and talk with us. Okay, you have heard the word, but you don't know much about it. Okay. Is this the case? Aryansh.
Hello. Yeah, yes, we have heard about Arduino a bit, and we have also used it in quite a few projects, but not everything. We know basics and about that. Okay, you are mute.
Okay, Sanchit. So first of all, let me explain you what is Arduino. Arduino consists of both a physical programmable circuit board. Arduino is not a name of a microcontroller. The complete board, microcontroller board, is called Arduino, and it also comes with a dedicated IDE. You all know what is IDE, Integrated Development Environment. You must have come across various IDEs while doing C++ programming or any kind of programming. So this IDE runs on the computer. Whatever code that this net is to be fed in this microcontroller board, that we type it in and compile in the IDE, and then we send that code to the microcontroller board. But it is important to point out that Arduino is not a microcontroller. Arduino is a complete platform which spans across software and hardware both. Arduino Uno is not a microcontroller either. It is a breakout board based on the Atmel Atmega microcontroller. Some of you who have worked with Arduino must have read the word on the microcontroller chip. It is written there. That is made by Atmega. There are various other microcontroller manufacturers also, but the Arduino is more popular, which comes with a microcontroller manufactured by Atmega. So what is Arduino? You can see the Arduino board here. This is the Arduino board. It has various other components that I am going to explain in detail afterwards. So already you have a lot of these boards in your home, but you do not actually know it. A microcontroller is a type of computer in the form of an integrated circuit. You all must have heard of microprocessors, Intel Pentium or AMD Radeon, or most of others like that. But you must have not heard much about the microcontrollers. Whatever we use in our PC, we need large computational capabilities. Hence, we use microprocessors, which are comparatively larger and more powerful in processing than a microcontroller. A microcontroller just manages few inputs and few outputs, which has these few input pins and output pins, and only very specific and very less tasks are there which can be carried out with the help of a microprocessor. With the help of a microcontroller. The microprocessor is the brain of the computer. Microprocessors are integrated circuits which process the instructions from a computer program, perform calculations, and send data to and from memory and disk. A microcontroller is a specific type of microprocessor. It differs from normal microprocessor in the following ways. It has a built-in input-output capabilities. The microprocessor does not come with the inbuilt input-output capabilities. It has to be it has to be arranged with a different dedicated input and output capabilities. But microcontroller, with the help of this input and output pins, it comes predefined and pre-built with input output capabilities. It can read and write digital and analog values and states, and can connect directly to the real world. That is, we can consider real world here as the input and output of the sensors, or the driving of a motor, or the blinking of an LED. It can directly interact with these components, not like the microprocessor. It can connect directly to switches, buttons, LCD displays, LEDs, relays, and serial ports. Microcontrollers are generally used for low to medium complexity specific tasks and equipments. This contrasts with the powerful number crunching microprocessors used in PCs, which handle a variety of software applications. Microcontrollers also, they are generally used in portable devices which runs on batteries, like that is digital cameras or smart watches, or any other digital equipment. So they are often low powered with a small current consumption. Unlike the heat sinked fan cooled microprocessor in a desktop computer, you all know that the desktop computer microprocessors have dedicated heat sink. They have various fans. They have various cooling mechanisms. Some of nowadays we also have liquid cooled microprocessors in many big and powerful PCs. So compared to the microprocessor in a PC, the RAM within a microcontroller can typically range from 64 KB to 64 KB to 1 KB. The program in microcontroller is usually stored in EPRAM. So here is another one difference. The RAM in our PC, we know it is called, the full form is random access memory, and whenever we switch off the computer and turn it back on, so whenever the power is lost, the data on the RAM of a PC is flushed out. But it is not in the case of the microcontroller. The microcontroller uses EPROM or EEPROM. This is type of a non-volatile RAM, in which the program does not disappear when the device is turned off, and hence it can be continuously wiped and rewritten. So what is this benefit of this functionality? So once you connect the microcontroller with the computer, you load a program in the microcontroller board, and then you can just disconnect it from the computer completely. The program will remain saved in the microcontroller's EPROM, and it can be used again and again till there is power supply, until the program is wiped out and it is replaced by some other program. So Arduino is an open source platform used for building electronic projects. Arduino consists of, they have repeated the same things, both physical programmable circuit board and an IDE. It is also provides a standard form factor that breaks the functions of microcontroller into a more accessible package that is made possible by the various input and output pins. Some other used microcontrollers I would like to discuss the names. There are Zilog, Intel 8051, Texas Instruments, Atmel. These are the companies that manufacture other microcontrollers. But the reason why only Arduino is so popular and is so heard of is because there are many people using it. Arduino is open source, so there are a lot of examples out there to work with. Additionally, the Arduino board itself is open source. That means there is a company named Arduino that makes Arduino boards that supports Arduino IDE. There are also lots of other companies that make Arduino compatible boards that can also be programmed in the Arduino IDE. So how do you understand that Arduino is suitable for your project? So does your project have an input and output, and do you require some simple logic between the two? For example, maybe you have a temperature sensor, and if the reading of the temperature sensor exceeds a certain value or it falls down below a certain value, you want to turn off the fan, or you want to turn on the fan, you want to turn on some, for example, air conditioning system. So at that point of time, you can use a microcontroller, or for example, a Arduino board in that case. If you can also have multiple inputs and multiple outputs, it is not just limited to one. The input output pins can be extended to the number of pins that are available in the Arduino board. For example, another test case can be if the temperature is in a particular range, and if the time is within this range and the sun isn't shining, then you want to turn on the light switch, or then you want to turn on a fan, and then at that point of time, you can use a microcontroller board. If your projects also involves using huge input streams like video recording or big computations, then the power of a microcontroller may fall short. because working with the video stream is a lot of data, and at that point of time you will have to move to some different methods, like you can use a Raspberry Pi, which is virtually a small mini scale computer, and which it can perform all the tasks that a computer can perform, but just its size is very small and it is very handy. You could use the Arduino board for this technology, for this task, like processing video streams or making big computational. But there are different and more powerful technologies already available, so we prefer to use that. But for basic logic between the input and output signals or input-output circuit components, we use Arduino microcontroller board. So here I have a 3D model of Arduino board I would like to share with you. Okay, is this visible?
Yes.
Yes, we are.
So this is the classic Arduino board. So this type of board is called Arduino Uno. There are different types of Arduino boards available in the market, and they differ in the processing capacity, in the number of input-output pins, and in the hello.
किसकी
Please mute yourself. Okay, so there are different Arduino boards available in the market. They differ in the types of input, output, number of input and output pins, and then capacity. So this is the port, USB port, which we use to feed the program in the Arduino board. This is the power socket that is used to power the board. There are pins which are dedicated or which have continuous power supply, like 5 volt, 3.3 volt ground pins. So all that power for these pins and other input and output pins also comes from the power supply. There is a DC power supply that needs to be plugged in this Arduino board. See, this is the microcontroller chip. I can zoom in here. Atmel M328P. This particular type of microcontroller chip is used in this board. This is the microcontroller chip, and this complete Arduino board is called the microcontroller board. And these are the input and power pins. So there are 6 analog input pins. These input pins can process and read the analog signals. There are some specific type of sensors that send analog signals. Some sensors send digital signals. So when that input type data type is of the analog type, then we plug it into the analog input pins. These are the power pins, set, reset. There's also a reset button at the corner of the Arduino board here, yellow colored button. This is the reset button that is used to reset the board. And what does it actually does, that you will understand when I will explain what type of code is loaded in the Arduino board. So a small question I would like to ask everyone. You can see this type of USB pin. Okay, so can you tell me which type of USB is this? USB type A, type B, type C?
type P
Yes, who was that? Okay, Unyansh. Yes, you're right. It is the USB type B port. And another component, these are the output pins. The pins that are marked with this tilde sign. For example, here pin number 3, pin number 5, pin number 6. These are called the PWM pins. So what is PWM? You must have heard, those who are working in or interested in electronics core, they must have heard about PWM. It's called as pulse width modulation. So pulse width modulation, what we do, we try to simulate analog output with the help of digital outputs. So in these pins 11, 10, 9, 6, 5, 3, which are preceded by this tilde sign, we can use them to generate analog type outputs also. Okay, so not much to be left here. Left here now. Now I will move to the next slide. So I described just this microcontroller board. So these are the components. So the pin number 1, the power USB or barrel jack. Every Arduino board needs a way to connect it to a power source. The Arduino Uno can be powered from a USB cable coming from your computer or a wall power supply that is terminated in this barrel jack. Barrel jack, here it is denoted by number 2. In the picture above, USB connection is labeled number 1 and power barrel is named number 2. USB connection is also how you will load your code into Arduino board. More on how to program your Arduino code that I will explain in the later part of the program. The recommended voltage for most Arduino models is between 6 to 12 volts. Your pins these 5, 4, 3 are the voltage ground pins which take power from the input. These pins on the Arduino board are the places where you connect wires to construct a circuit. They usually have black plastic headers that allow you to just plug it wire into the board. The Arduino has different types of kinds of pin. These are, I've already discussed them, the ground pin, the 5 volt, the analog pins, the analog input pins, here denoted by number 6. These are the 6 analog input pins. These pins can read the signal from an analog sensor. For example, temperature sensor sends the data in an analog form. So whenever you take input from a temperature sensor, you will have to plug it into this analog input pins. Pin these 7 or 8, these denote the digital pins. Across the analog pins are the digital pins from 0 to 13 on the Uno board. Why I'm specifically saying Uno, because the number of pins differ between the different Arduino boards. So in this case, it is from 0 to 13. These pins are used for both digital input, like telling if the button is pushed, or they can also be used for digital outputs, like powering an LED. The pin, this 9 number pin, it stands for analog reference. You can, most of the time it is not needed by us, but its function is to set an external reference voltage between 0 to 5 volts as the upper limit for the analog input pins. So that is the pin which can set the reference for the analog input. Is a reset button. The reset button will temporarily connect the reset pin to the ground and restart any code that is loaded on the Arduino. This can be very useful if your code doesn't repeat, but you want to test it multiple times. So when does the code repeat and when it doesn't repeat, that will also I will explain in the further part of the program of the workshop. The pin number 11 is the power LED indicator. So whenever your Arduino board is switched on and the code in it is running, it will be indicated by the power LED. It will be switched on. And if it does not switch on, there is a good chance that something is wrong. And then the number 12 are the TX and RX LEDs. So what is TX? TX stands for transmission, RX stands for receive. These markings appear at various places in electronic devices, and they are responsible for serial communication. There are 2 places in the Arduino Uno where the TX and RX appear, once by digital pin 0 and 1. You can see here. Digital pin 0 and 1 are labeled TX and RX, and the arrow there also shows the flow of data. That this TX means the data is sent out from the Arduino board. RX means data is received by the Arduino board. So whenever these pins are working, these LEDs will lighten up, so you can check whether the correct transmission receiving process that you have coded is happening or not. This is called the IC. So in that 3D model, the IC shape was a bit different. Here the IC shape is a bit different. This is the microcontroller. It is the brain of our Arduino board, the main IC. This IC differs, as I've said, between various different Arduino board types. Different Arduino boards can have different make and different version of the microcontroller chip. This is the voltage regulator. This also we do not need to engage with, but in most of the times, if the voltage is not within the specified range, to prevent the board from damaging, so we can regulate the input voltage by using this switch. And also the upper limit for Arduino board is, so I think it is 20 volts. So anything greater than 20 volt when plugged to the Arduino board will of course damage the complete board. So what I was saying, I was specifically mentioning Arduino Uno. So there are other type of Arduino boards also. For example, this is the type of board. It is called LilyPad Arduino. So LilyPad is a wearable e-textile technology developed by some organization. Each LilyPad was creatively designed with large connecting pads a flat back to allow them to be sewn into clothing with conductive thread. The lily pad also has its own family of input, output, power, and sensor boards that are also built specifically for e-textiles. And this board is even washable. You see here the number of input output pins differ, but the overall structure remains the same. There is a reset button, there is an input power supply, there is a microcontroller, there are input and output pins. There are some LEDs that indicate whether the board is running or not, the code is running or not. This here is the Arduino Mega. So obviously it can be seen there's large number of input and output pins as compared to our standard Arduino Uno board. It can be, I can call it Arduino Uno's big brother. So it has 54 digital input output pins, of which 14 can be used as pulse width modulation outputs. There are 16 analog inputs. There is USB connection, a power jack, and a reset button. The overall structure is still the same. It contains everything needed to support the microcontroller. Since Arduino board is open source, any versions of Arduino still exist. If you Google, you will get more and more versions of this Arduino board, which other companies can manufacture. And depending on the need or the field they are working with, they can use this Arduino board and they can make it up to their convenience. Also, as you can see, the Arduino board here connectivity, there's only one method of connectivity, the code that comes into Arduino with the help of this USB pin and the input output pins. But Arduino board is still not connected to the internet, or we do not know how it will take the data or what kind of data it will receive. So that task is carried out by sensors and various other modules. So some sensors I have here images for discussion. So this you can see the magnetic Hall sensor. So it detects the presence of magnetic field. You have to use a Hall sensor. This is called magnetic Hall sensor. It can be used as a magnetic field detector. So these are these pins. These pins need to be plugged into the respective input pins of the Arduino board. This is the infrared obstacle avoidance sensor module. It is used as obstacle avoidance type applications. For example, if you are developing some robots, some drones, so in that case you can use this sensor. It is consists of infrared transmitting and receiving LEDs. These two pair of LEDs, you can see the black colored and the white colored one. The one transmits infrared light and the other receives the infrared light after reflection, and that data is used to measure the distance between the obstacle. And this white colored sensor, this is PIR sensor module. It is called passive infrared sensor, or simply PIR sensor, which allows you to detect or sense any motion. So you must have come up across the lights which are of the type that whenever they detect any motion, they are lightened up. For example, the lights that are fitted in the courtyard, there are examples of the smart LED lights, so that are lightened up automatically when they detect any motion or detect any person coming. So this sensor is used there. Whenever it detects any motion, it sends out the signal, and that signal we can use to perform a variety of tasks. You can implement motion detection with the help of this sensor. This sensor is called rotary encoder module. It is a 360-degree rotary encoder module. It is an input device that provides both direction and of rotation, and as well as how much amount is rotated. So whatever signals it sends with these pins, so based on that signals, the Arduino code, you can code it in such a way that you can understand at what direction it was rotated and how much it was the module was rotated in degrees. So that data you can use to perform various other tasks. This is a passive piezo buzzer module. If you want to control the frequency of the tone from the buzzer, then we use the passive buzzer module. This is the passive piezo buzzer module. So that we use for generating a buzzer sound. These tones of this module range in the frequency of 1.5 kilohertz to 2.5 kilohertz. This is the speed sensor module. If you want to detect the speed of rotating object, then we use this sensor. It is based on same concept that we see here, infrared transmitter and receiver. So these two LEDs are now here housed between these two. You can see the labeling also. This is the symbol of an LED. So these here the LED sets, and whatever there is rotating object you place between these two objects, and with the help of the infrared light, it can measure the rotation, speed of the rotation. This is a gas sensor module. It is used very commonly used in safety related applications. This is used to detect smoke, carbon monoxide, hydrogen, and other gases. There are different types of sensor available for different types of gases and combinations of gases. We can use this sensor to devise a very basic type of smoke detecting alarm, or in cars, for example, if there is any excessive rise of carbon monoxide levels or any gaseous fuel leakage in the car, then we can devise a safety device which can use this sensor and a buzzer from this slide to detect to make a alarm that will alert the driver and the passengers. So this is the barometric pressure sensor module. It is an old but very useful sensor. It is used for various meteorological applications. You can measure the temperature, the atmospheric pressure to determine whether there will be rainfall in the near future or not, that you can devise. Here, this is the DHT11, DHT12 humidity and temperature sensor. It is also a very common type of sensor, which can be used in conjugation with this barometric pressure sensor to devise some climate or weather forecast device. There are various types of module that we use for connectivity. As I already said, our Arduino board is still not connected to internet. So how it can be part of Internet of Things, right? So for example, this is the motor driver module. This motor driver module we use to connect stepper motor or any normal type of motor with the Arduino board. For example, if after receiving some input and processing on it, if you want to do some actions like rotating a wheel or turning off wheel or turning off for example, if you use an obstacle detection using the infrared sensor, and after that input taken, you want to rotate the wheel or turn the drone or turn the cart in other direction, so you can use this motor driver module that will drive the wheels in the particular direction. This is the LCD output module. This also is connected to the output pins of the Arduino, and whatever characters or whatever numbers or whatever readings that will be shown here, that can be programmed with the help of Arduino's code. So for example, you can you must have heard of this project like number of followers tracker on Instagram. So with a type of very basic code, you can measure this. You can make the number of followers on Instagram to be updated on this LCD output. This is the Bluetooth module. The Bluetooth module is used to make Arduino board Bluetooth ready. You can connect your mobile or can connect other application of the devices such as headphones, which are already Bluetooth enabled with the Arduino board, and you can send signals to that, for example, headphone or mobile with the help of the Arduino. This is the GSM module. So everybody knows what is the GSM. GSM stands for our cellular connectivity. So there is a SIM card embedded in here. So for example, if you want to develop a health tracking device with minimum intervention, for example, you want to make a device that would send SMS to nearby hospitals whenever the health of the patient wearing it deteriorates. For example, blood sugar drops below a particular level, or blood pressure is shoots up very high, and at that point of time, you want to send emergency SMSs to nearby hospitals or ambulances. So that time this module you can use. So it will be completely interruption free from the user. It will function on its own. It will have its own dedicated SIM card, own dedicated antenna. It can send whatever symbol, whatever message that is coded in the Arduino code. This is a GPS module. GPS module is used to detect the latitude, longitude of the particular position of the device. This detects the position of device and sends to the Arduino board through its input pins. Then we can process the latitude, longitude to carry out of further tasks which are as required. This is the Wi-Fi module. The Wi-Fi module is used to make the Arduino board Wi-Fi ready. And we can use it to connect to a Wi-Fi network. So for the type of applications like data collection for our various machine learning projects, you want to collect data for temperature or you want to collect data for soil moisture content, humidity, and you want to continuously log it into somewhere in the cloud. So that time you can use this GSM module to log it into Wi-Fi, and then it can be programmed to store at some location, or at you can use some API to store it at some location in the cloud. Then now we are going to proceed with Arduino and its installation. So today I will only tell about how to install the Arduino IDE in your PCs. And the next workshop, I will explain how to install Proteus and how to use the simulation to devise any solution or any circuit that you wish. Proteus is a very useful tool for electronics engineering students. I have used a lot when I was in second year, first year. So it will help you to run various circuits that you encounter in your day-to-day learning also, and it will also going to help in these events. It will help you in Digisym. It will help you in X-IoT-A. So for this, I will need a volunteer. Sujal,
Yes,
can you
Bhaiya.
please share your screen?
Yes.
Okay, Sujal, open Google Chrome. All other participants can also simultaneously do this. It's a very small flow of events. You can easily complete it during this workshop itself.
My screen is visible now.
Yes. So type
What I have to search?
Arduino IDE.
First
Open
link.
the first link. So here you can see download options, Windows 10. So whatever is your operating system, according to that, you may download the version. If I think yours is Windows 11, so Windows 10, and you will click on that option.
Just download.
Just download, yes. It will take some time, around 160 MB. Okay, double click on the installer. Click on I agree. Click on install. So meanwhile, is anyone other following these steps? Can just raise your hand or message in chat box. Is someone else also doing the steps with us? So Sachin. Hi, Arduino you can power with USB connection also. When you power with USB connection, there is no need for dedicated power input pin to be connected to the Arduino. By USB, it can both access the code as well as it can take power from the USB connector itself. But once you have loaded and you disconnect the USB, then you will need a power input for the Arduino to run the code that is already loaded in the ROM of the Arduino. Okay, Samit and Prateek are with us. It is taking quite a time with it.
Should I try to reinstall it as it is taking much time?
Okay, just try it again. But how will you exit now? There's no cancel option also.
Mhm.
Okay, Samit. Yeah, he has also installed. Now open the application. There must have been a shortcut created at the start menu or the text. Okay, this is on the desktop. And for the rest of you, if you go navigate to the files section of this team, first of all, those who haven't joined the MS Teams, I request you to join as soon as possible. So in that the files section, I have uploaded this. There's a PDF mentioning all the required steps and all the other files that or all the setup or all the applications that will be required. I will upload at there. So you are free to access it from there. And Sujal, one small step is remaining. So go to File menu, select Preferences. And here check whether the compilation box is ticked that is shown next to the show verbose output during. Here click on the compile text box. Okay, click on OK. So this is one small step that need to be followed. What I was telling about the Arduino code and the reset button, and then I will explain it here. So these are the two parts of code. The one function block, it is the setup function block. So the setup function block runs only for once. Whenever you power on the Arduino, the code from the ROM is started run, and the setup block executes only one time, and the code block loop keeps on executing continuously as long as the Arduino receives power. Whenever it stops, only when the power of the Arduino is stopped. So when you press the reset button, that time the power is switched off and switched on. At that time, again the setup block executes once, and the loop block then continues to execute infinite number of times. So here I think it is already comes with a preloaded, it's very simple code in the setup function. First of all, we demarcate the pin mode as input or output with the help of this function pin mode. The first argument is the number of pin, the 13th number pin. The second argument, okay, Samit, go to file. Sujal, you may also follow. Go to file, preferences, and this line show verbose output during. That here the compile tick checkbox must be ticked. If it is ticked by default, no problem. But if it is not, tick it and then click on OK. Okay, Samit. Okay, so at this code, what it does, pin mode 13 is designated as output. So what we will do, digital write in the loop. So this loop part of the code will execute it repeatedly. So digital write 13 comma high. So whatever is connected to 13, maybe an LED is connected to pin number 13. It will send a high signal. So high signal, everyone knows high means plus 5 volt. So it will send plus 5 volt. Then delay 1000 means it will wait for 1000 milliseconds. 1000 milliseconds equals 1 second. So 1 second, the output in the 13 number pin will be kept high. And then next statement will be executed, digital write 13 comma low. So then the output at the 13 number pin will be kept low. that will be kept as it is for another 1 second, and then again the loop code will be executed. Again the first statement will be executed, digital write 13 comma high. So pin number 13, high output. So if it is LEDs connected, it will be glowing. It will be going for 1 second because then a delay line is there for 1 second. Then the low output will be sent to pin number 13. The LED will stop glowing. It will stop glowing for another 1 second. Yeah, as delay output is here set for 1 second. Again the code block will be executed, and this will keep on running continuously. Okay, so there are two modes for operation of Arduino. First mode, you can connect the USB connector to the Arduino board. You can send this code to the Arduino. That will learn the later series of the workshop how to send it, how to load it into Arduino. And then once it is loaded, it is saved in the Arduino ROM. The Arduino will receive input power supply from the USB connector. And once you switched on the Arduino, this code will be continuously executed, which is loaded in the ROM. Whenever you make changes here in the Arduino IDE, you will have to again and again send it into the ROM of the Arduino. So that for that you will have to execute a command from here. You will have to send it to the Arduino unless and until the changes will be not be reflected in the flow of outputs of the Arduino board. Okay, or other method of running is first load this code in the whenever, if you know that the code is full and final, then you can just load this code in the Arduino board and you can disconnect the USB connector. Then you can just give source of power supply. You could give it from AC to DC connector, just like our phone chargers, or you can just connect a small battery also to the Arduino input board. That also works. And then you can make it as a completely separate device which does not need to be plugged into the laptop or to the desktop. So these are the two modes of the operation of Arduino board. So that was it. If anyone has any doubt up until here, please ask in the chat box or unmute. So first, tell me, how many of you are not familiar with the C or C++ code? Sujal, please open the previous window. The IDE, yes. Okay, so how many of you are not familiar with C, C++ code? Most of you must have C programming in your first or second semester. So I think there's hardly anyone who is not familiar. This all the Arduino code, as you can see, is very similar to C programming. And once you know C programming, you know the various loops, the while loop, for loop, the various if-else cases, the switch cases. That is more than enough for this. No different coding knowledge is required. Very basic coding knowledge works here, and more advanced knowledge is not required. So what I was saying, I will discuss some examples of code that you will run in the Arduino. Sujal, okay, you can stop presenting now. Okay, is my screen visible? Sujal?
Yes,
Yes,
yes, it's
Okay, steps. So install Arduino IDE that we have created, we have completed in today's workshop itself. In the next workshop, we will proceed with the next steps. You can do on your own also. There is a tutorial uploaded at the file section of the Teams. If you are doing it by your own, it's very good. If not, I will explain it in the next workshop. So this is for one code of Arduino. I think this code was preloaded in the IDE. I just explained it now. It was blinking off an LED. The same code C but here what changes are made. Pin mode 2 comma output. So pin number 2 is set as output here, and whenever the Arduino code is run, so the LED that is connected to pin number 2 that is made to light up. This is the difference. To better explain, I can see the board. You can see the pin number 2. So here is the pin number. These are not the pin number 2. This is pin number A0, A1, A2, and they will be called accordingly in the code. Also, they will be referred as A0, A1, A2. And these are the digital pins, so that they will be referred by their names. But just if it is pin number 3, we will not use the tilde sign there. We will use only 3. So this is the pin number 2. This is the pin number 13. You can see pin number 13 can be used as a PWM output, pulse width modulation output, but not necessarily every time. It has to be something analog output. It can be used as digital output as well. These pins which are marked with the tilde sign can function in both the ways. So this is pin number 2. This will be if you select this pin in the code, this LED connected to pin number 2 will light up. Or if it is selected pin number 13, pin number 13 will light up. This okay, this someone has had that doubt. TX1, RX1. So this will be used for serial transmission and receiving of information. So this will also we see there is a serial monitor output. So that will, for example, that can log different types of functions or different types of messages that are sent by Arduino board. So we can use this output to connect it into serial output monitors, and that will keep on showing the output or the various values that are taken by the sensors as input. There we can log it into the monitor to monitor during the phase of design of our electronic device. We can use that as an check to see what outputs are actually we are getting, and whatever we are connections we have made that are correct or not. So that the serial output we can use. The serial output can be also used to be as in input to the other modules like GSM module. The TX1 RX1 input pin can be used as input for the GSM module. Whatever signals that are generated by the GSM module, the coordinates that are mostly in the form of serial output. So that output pin can be connected to this input pin RX1. So then Arduino board will receive the value of coordinates. Okay, I forgot to switch the screen. Someone could have pointed it out until then. Is the board visible? Someone apart from Sujal, please unmute and tell.
Yes.
Yes. So did you listen to whatever I did talk? Hello? Who said yes now? Please respond. Did you listen to whatever what I said just now? Yeah, no problem. These are the transmission and receiving TX1 RX1 pins. Whatever I just said. If some sensor is some module is generating serial input, and that we want to take in the Arduino board, so we will connect it to the RX1 pin. Or if some module requires serial output, for example, serial monitor or a GSM module that requires a serial output, that we will connect to the TX1 output pin. And whatever I said in the code, if pin number 2 is designated as output pin, then the LED connector to pin number 2 will light up. Or pin number 13, the LED connector to pin number 13 will light up. And these are the analog pins. They cannot be used as input pins. And whenever they are being referenced in the code, they will be referenced with the names A0, A1, A2, A5 only. Okay. So this was the first code that was I have already explained previous part. Okay, so next code is LED display, LED bar display to measure LED bar display to measure the value of voltage. So this is the example in which you will see what is the use of the analog input pin. So here this constant, these are defined outside the setup and the loop blocks both. So these will be treated as constant throughout the execution of the program. So here this constant int analog pin is equal to A0. So A0 we are going to use analog pin A0 as input. This is a constant LED count that we have defined as 8. This is the number of LEDs in the bar graph. So 8 different LEDs we are going to connect with the digital output. So this is the setup function. For this setup, what we have did, pin mode. So what we have did is we have generated an array of numbers starting from 2 up to 9. You can manually here set up pin mode 2 comma output pin mode 3 comma output pin mode 4 comma output up to 9, or you can use a for loop here to do in fewer number of lines to save the amount of copy paste that you will be doing. So this LED is the variable here. So LED pins square bracket, this LED will reference to the number to that element. For example, if it is 0, then it will refer to the first element. If it is 1, it will refer to the second element, and that will be set as output pin. Okay, so in the loop function that will be executed continuously throughout the execution of the Arduino code. So we have defined an integer sensor reading that will this is the analog read function. The analog read function is to take inputs from the analog pin. So this we will map to a range from 0 to 8. Since the LED count here is 8, so from 0 to 8 we will map these. So how this works? This works on a simple the function we use in coding, which is known as the greatest function less than equal to the number. So with the help of that, we will map these readings into values from 1 to 8. So for example, when the reading of the potentiometer or the voltage is minimum, only one LED will light up. When the reading of the potentiometer is highest, then all the 8 LEDs will light up. So now we have another for loop. We have integer defined this LED ranging from 0 to LED count. Okay, it will range from 0 to 7, so it will cover all the 8 LEDs, which is the size of the array LED pins. Okay, so is this int LED level will give us the level of the voltage. For example, if the level is 7, okay, so if this LED which starts from 0, if this LED is less than the LED level, for example, in a case, let us consider, for example, if it's LED level 7, all the 7 LEDs should light up. So if this LED is less, all the 7 LEDs out of the 8 LEDs should light up. Then if this LED is less than the LED level, then we will write the LED pin at that position to high. Otherwise, we will write the LED pin to that position as low. This is an important step to carry out. For example, if you do not do this step, okay, the first time the reading was full, that is all 8 LEDs had to be lighted up, and this value of LED level was 8. Okay, so this if loop will execute from 0 to 7 when the value of this LED is 0 to 7. If it is 0 less than 8, it will this if statement will get executed and the output will be high. For 0, 1, 2, 3, 4, 5, 6, 7, all are less than 8. This statement, if statement will be executed and the output will be set to high. But if statement is executed, then else will not be executed. Then in the second iteration of the loop, let us consider first level was high. Okay, so all 8 LEDs has to be lighted up. Then at this time, let us consider the level was only 2. 2 LEDs here are to be lighted up instead of all 8. Okay, so again it will go through this flow, and in this if statement, this LED level it was rated from 0 to 7. Okay, so 0 is less than LED level, which is here 2. Okay, 0 is less than 2, then pin number 0 will be written as high. If and then in the next iteration, this LED will be 1. So if 1 is less than 2, again if statement will be executed. Then if this LED is less than LED level, then again in the next statement, if the next variable is 2, if 2 is less than LED level, 2 is not less than 2. Okay, so only 2 LEDs, 0 and 1 number will be lighted up. And then in the else block will not get executed here. So what we are doing, the writing digital LED pins to low, so that is not getting carried out. So whatever LED pins were written high before, that will be continued to output as high, because the code, the while loop will run again and again, and this LED state which will write digital write, this state will be maintained as high in the S pin also. So it will be an inaccurate representation of the data. Even though the voltage has decreased, the LED indicator bar graph has not gone down. So for this, these both statements are equally important, and these small mistakes you will come across while writing code for the Arduino. You will write the code, you will load it into the simulation, you will check how it is running. You will find mistakes in that, you will get frustrated in the process. You'll have to make changes in the code, and it will be a very interesting process to go through with. And I really wish you all participate. Let me tell you, X-IoT-A is one of the easiest event in the complete Udyam series. It is very easy to complete. The first workshop we'll have a problem statement. We'll try to keep it very simple and approachable by all. And the second problem statement we have, which will be an open problem statement. I have mentioned this during our Udyam's first event, that second workshop, second problem statement will be open problem statement, and you can devise solution to any real world problems that you encounter. But the first problem statement, we will give a simple problem statement to you, which will be approachable and solvable by everyone. So I wish that you all participate in the event. So these are we two people, myself Ajinkya and Krishna Priya. We are the coordinators for the event. For any queries related to event or even related to Udyam, related to installation, related to Arduino, any guidance, you are free to contact us at any point of the time. These are WhatsApp numbers, these are email IDs. You can even personally come and meet me. I live in the Vishwakarma Hostel, room number 128, or you can contact our co-coordinators Sujal and Neeraj. They both are from second year electronics engineering. They may be your batchmates, but any queries or any doubts or any feedback, any suggestions, you are free to tell them also if you are not comfortable in contacting your seniors. But to be frank, we are very friendly. Whatever doubts, we will try our best to address them. And I will mark this as an end of our workshop 1. So these are the links to our feedback form and WhatsApp group. I have also entered them in the chat. So in the feedback form, please give us a feedback. How was our first workshop? If any suggestions you have, you are free to give that suggestions too. And now I request everyone, please, if you have any doubts, you can please ask, unmute yourself right now. Or you can type it in the chat box. I'll address you from there. And one more thing, please try to attend all the workshops. They are very important. The first workshop will be an online workshop for all the events, but from the second workshop onwards, we will have an offline workshop. It will be more engaging, more interesting. And there are special points also for attending the workshop while making your final submission. Your attendance will also be taken into consideration. Your activity, your engagement will also taken into consideration. So please be aware of it. Okay, I think there are no queries. Krishna Priya, can we end the workshop now?
If there are no queries, we'll end the workshop. We'll also attach the resources required and keep checking the teams in the WhatsApp group.
Make sure to join the WhatsApp group at least, and also the Udyam teams. And if you do not have any queries now, if you come across any queries or any doubts later, you are free to put it in the WhatsApp group, so you can contact us also.
For now, I've attached the resource to study more about Arduino in the chat box.
All the functions, all the various, for example, the function we have analog read function or digital write function or digital read function. That all functions you can study well on this resource. I will also update it in the teams. I will make a post about it. And okay, then officially I declare this workshop to be completed, and see you all in the second workshop.